many x's and f's. Okay, but looking at this function, if I look at the limit as h goes to 0, okay, and I'm using this, okay, I'll erase the other one. We simplified him. Okay, so now f at x plus h. That means, if I said find f of 5, you would put a 5 in for the x and do whatever operation is there. So when I say to find f of x plus h, I mean replace this x with x plus h. So this is x plus h, quantity squared, minus f of x. Well, f of x is given to me right here, so it's just minus x squared, whole thing over h. So just like with the other limit problems, obviously this isn't going to work. I can't let h be 0. So I have to find a way to get that h to cancel out at the bottom there. Then I can let h equal 0. Okay, so I'm going to FOIL this. Remember, this is not x squared plus h squared. This is x plus h times x plus h. So I have the limit as h goes to 0. Then FOIL, remember this guy times both and this guy times both. And then combine any like terms that you have. Okay, here's a little trick. No one else is going to show you this. Okay, and you're going to be doing this a lot for like the rest of the term. When you're multiplying stuff and you have more than one letter, more than one variable, it's helpful when you multiply them. I put them in alphabetical order. Here's why, okay? Don't write this out as I'm going to write because I'm just going to erase it and fix it. But, okay, x times x is x squared. X times h would be xh. H times x is hx. H times h is h squared and minus x squared over h. These are like terms, but they don't look like it. Like, you know what I mean? And what if you had 3 variables? Or what if you had a whole bunch more terms? It gets too hard to pick out the like terms. Remember, the order that you multiply doesn't matter if the x is first or the h is first. So I automatically put them in alphabetical order as I multiply. Okay, so x times x, x squared. X times h, I'm going to write as hx. H times x is hx. H times h, h squared, then minus x squared over h. Okay, so here I have my x squared, then I have 2 of these. So that's 2hx plus h squared minus x squared over h. Now, what can I do in the numerator? What's going to cancel? This guy and this guy, right? So this gives me the limit as h goes to 0 of 2hx plus h squared over h. Hopefully you can see now, yes, I'm sitting down, you can see that I can factor an h out of the top, and that I can reduce with the bottom, and then I can let h equal 0 without worrying about being undefined. So I'm going to go all the way over here for that. Yes, there's a dresser in the way. Okay, so the limit as h goes to 0, factor out an h, and you have 2x plus h over h. Those are going to cancel, and you're going to have the limit as h goes to 0 of 2x plus h. Now that you don't have to worry about division by 0, you can go ahead and let h equal 0. So the whole thing is 2x. Some of this garbage on here. Oh, I call calculus garbage. Don't freak out. We're not doing anything with trig. I know tangent is a trig word. There are two trig words that we use, but you don't actually have to do anything triggy with it. Okay. Let's go back to this. All right, suppose that's our function, right? Okay. A tangent line hits your function at one and only one point. Okay? So let's write that. So there are infinite numbers of tangent lines, okay? Could be that point, could be down here, hitting it just at this point, okay? The slope of the tangent line at that point, that gives you the instantaneous rate of change. How fast is your function changing at that point, okay? That's a tangent line. A secant line would be like from here to here. A secant line is just a regular old straight up line, okay? And that gives us, the slope of a secant line gives us the average rate of change. So let's write down about the secant. Okay, now it just seems like we're just doing the algebra, right? But we're really not, okay? When we find the slope of the tangent line, what we're finding is called the first derivative of the function. Okay. You know what? I'm gonna stop the video there, and you guys are gonna need to kind of get caught up with this stuff. I will put some other problems on. I'll email them to you, or I'll put them on Canvas, one or the other. You know, yesterday I sat down to do a bunch of stuff, and the whole system was down, so there's that. Okay. Love you guys. I hope everybody's staying safe. Bye.